Welcome again. In this session, we'll be talking about something very interesting. This has been the buzzword in the industry for quite some time, and this is a solution which enables us to go a step beyond the previous solutions. This is what we call neural networks, or properly referred to as artificial neural networks, or ANN. ANN, or artificial neural networks, are computational models that are inspired by the way biological neural networks in the human brain processes. Let's take a look at the neurons that we have in our brain. So a neuron basically comprises of dendrites and synapses. Synapses are responsible for gaining the stimulus, and the dendrites communicate these responses to the cell body. The cell body then performs a function on this stimulus, and then the output is reflected back through an axon to the particular part of the body. Let's try to build a model out of this. So here we can see that a synapses gets an input called x0 from its environment, and then the synapses attaches a weight to this particular input. The weight is actually the importance that we give to this particular input. Now, from all the synapses, we transfer all these inputs along with the weight to the cell body. In the cell body, along with the combination of all these inputs and weights, we also have an activation function. Now, this activation functions are functions that are triggered when certain pattern of data or certain threshold of data is received by the cell body. And once these activation functions are triggered, we get the output, which is a function of the inputs and the weights that are present in the cell body. So this is how a neural network or an artificial neural network also works, where the first part, the input data, is analogous to the synapses and the dendrites. So in the input node, we get the inputs of the data that we are using. We assign certain weights, that is certain importance, to this input, and then communicate it to the next layer. The next layer is called the hidden layer. In the hidden layer, we perform certain operations on this input along with this weight, and this hidden layer is again associated with a activation function. This activation function also is basically a threshold value, which when crossed gives us a response. This activation function is a very important, and we will be discussing this in the next slide. And when this activation function is triggered, that is when we cross the threshold assigned in the activation function, we get the output, which is captured in an output node. Now let's go back and talk a little more about the activation function, as it is the essential crux of neural networks. Now, activation functions can be of various types. Let's take a look into what types of activation functions we have. As you can see on the screen, we are showing 6 of the most commonly used activation functions. Can you recognize any one of them? Yes, the first function, the sigmoid function, is something which we had used even for our logistic regression. So a clear characteristic of these functions are, given a particular threshold, we do not get any kind of output when the values are lower than the threshold. For example, in the sigmoid function, if our input or a value of x is less than 0, we won't be getting any output, that is, the output is equal to 0. And at the point or at the threshold of 0, when we cross it, we get an output of 1. Similarly, we can look into functions like ReLU, which is commonly used nowadays. So all of these functions have that characteristic in common, that is, they have a particular threshold, and when we cross this threshold, we get an output. With that, we would conclude with the theory of neural networks and try to understand where neural networks can be applied. So a major use of neural networks are in natural language processing. In natural language processing, we essentially take all the textual or audiovisual data that is being present, and we try to understand what sentiments are humans trying to communicate through this text or audio data. This again is a problem that is very efficiently solved by neural networks. We have the input data as the text or the audio that is being used. We develop a neural network which consists of a lot of activation functions and hidden layers, which tries to generate the output, which is the sentiment that we are trying to predict from the natural language. So with that, I would conclude this session on neural network. Hope this was interesting to you. Let's meet up on the next session to continue our discussion. Thank you for listening to me.